Hi everyone. So at this point, all that you've done is run your very first Python program, but I want us to make use of Jupyter Notebooks now to do something a little bit more interactive and introduce some concepts that we're going to be exploring in the next few weeks. We'll go into a lot better detail in the next few weeks, by the way, but this is just going to give us that first glimpse into what we're going to be learning in Python. And I also want us to pay attention as we go through this first notebook to parallels back to R, if that is relevant. We're going to maybe talk about how we can transfer some of the R concepts we learned in the first half of the course to then apply them to the Python programming framework. So let's get started. A little bit, I just kind of took chunks or cells, not chunks, but cells of code here and used the Jupyter Notebook to put together kind of a module that I do want you to step through. So if you click on each one of these cells as we go through, for example, this first one is just a heading. It's coded as a markdown cell within the Jupyter Notebook. And if you just, again, Shift Enter will get that run for you. So as you see, I made a little comment. This will step you through another first Python program that includes some essential components we'll be learning in more depth in the next few weeks. So follow along with me. There's an interactive component, so stop the video now, open up this notebook within your Jupyter Notebook environment, and so that you can run through, maybe stop the video as you go through and make sure that you can do each part as I do it. So we're going to skip the titles and other kinds of the markdown cells, I guess I should say, and just make sure we can do this. So this first coding cell is going to import the module random, and we're going to use a function from that module random to generate a random value. Integer from 1 to 100, and you'll see that below in the next cell. But for right now, let's think parallel transferring concepts from R to Python. In R, what did we have to do every time we wanted to use a function that was from a particular package? We had to first install that package. That does not really transfer into Python, but we had to load it. And this is much like loading that package as we did in R. So we're saying we need to use something out of random. And in particular, we're going to be using this randint. So just generating a random integer. Okay. Right now, we're going to go into this a lot more detail, like I said, later in the course, the modules. But right now, this is kind of your first glimpse. It's not everything we're going to learn for each of these. The next cell is, by the way, if you're running this Shift Control, then you know you have access to this randint function for the next cell. For the next cell, we use the randint function. Notice we're going to randomly generate an integer between 1 and 100, and we're going to store it in an object number. This transfers almost exactly. The only thing different from R is that our random generation function, we would have used runif in R, but here we're just going to generate specifically an integer value and keep it simple in Python. Then the following step is I just print. So notice the syntax for printing. This is for Python 3 in particular. If you happen to be using Python 2, it may look different. And we're going to randomly generate. You'll see the first time I ran this cell, I got 17, a number indeed, between 1 and 100. If I run it again, I'm going to get a different value. Okay. By the way, I could go up here, run it again. I got yet a different value. So make sure you can run that and that you get a different value between 1 and 100 each time. So this next one, we're going to get user input. This is something we never really used in R very much. It's I don't know, it's not as emphasized, I guess, within the R programming environment. And in this, we take input. So notice the function input, and it says, give me your best guess, okay, of a number. So this would be like setting up that game if you were going to play it with somebody. Then we round. That int function is going to round it to an integer value. We'll test that out in just a second. Then we're going to print a logical test that sees if is it equal to the number or not. And I just added this. I know it's kind of useless because it looks a little hokey down below, but I thought it would be useful to talk about this because this expression, while the top expression, the first line, does not really transfer well from R, the bottom does. That's a logical or Boolean test that is kind of our first take on using that within the Python programming environment. So let's try this out. Notice when I first run that cell, so I just did Shift Enter, I'm going to need to enter something. Well, we know my number is 44 here. So let's put in something that we know is not equal. So I'm going to put in 66. And then it gives me a false. Notice it keeps that value up there next to it. I could do a little formatting and, add some space or something like that. I'm not going to worry about it. Let's run it again. Let's say I want to try again. So this time I'm going to put in 33. It still gives me false. Well, since we actually know the answer, let's make sure it's going to test right. And yes, when we get it exactly on the nose, it gives us a true. Well, that's not, you'd have to guess a long time to keep going through all the numbers 1 to 100. So let's do something a little bit more sophisticated here. And again, we're going to be able to transfer some of our concepts that we understand from R to be able to do this. So I wouldn't expect you at this point to be able to write this whole logical programming structure here, but you'll be able to understand it. So notice what the very first, we kind of took this guess equal number or number equal guess test here and said, if number equals guess, then you're right. And you just say, good guess, lucky, right? But we have other two possibilities. The number could be bigger than the guess, the user inputted guess, or the number could be smaller than the inputted guess. So notice we've taken care of all possibilities here. So if the number is bigger, then you say guess something higher. If the number is smaller, you say guess something lower, right? Notice the programming structures or the syntax. You start with an if. What's different from R is you don't surround these in parentheses, but instead you just add a space and then print your Boolean test. It ends with a colon. Then the indentation here is really important. For instance, watch. I have that print good guess, so in the lucky case that they get it right on the dot. But if I take away a space here, like that, it's going to tell me, it's going to make it red. And what that does is that's telling me the indentation is not correct. Now notice the first time I backspaced, it did this. Well, this is not tying that print statement back to that if statement before. That's just going to print good guess every time. And that's not what we want. We want to tab that in so that if the number is equal to guess exactly, then it prints good guess. Okay? Then we continue this if-else sequence by saying, or the number could be bigger than guess. Notice it's not else if as in R, but just elif, okay? And then notice here again, the indentation is important. If I don't do that same indentation, I'm gonna get an error. It's not gonna let me run it. Python really emphasizes correct kind of indentation structure in order to recognize certain programming forms, okay? That is very different than R. R does not do that at all. But notice also the colon there, also important. Then we have else colon. Why not number less than guess? Think about it. This is our last possibility. So we can just put else. There's nothing else that could happen. Okay, so let's test this out. Make sure you understand that code. And it tells us good guess. Why? Because our last guess is 44. So let's make sure, let me put in up here. We have to kind of artificially do this. I'm going to put in 56, so that's a number too high. So now it tells me guess something lower. So, okay, I'll guess now, pretending like we don't know, 23. Now go here, guess something higher. So right there, we've got all the basic components. of a program that would play this little game. I'm going to send out the program to you so that you can add it to this notebook page and then show me that you can run it and you can play the game. Okay, just give me like a screen or a printout, the final version as you run the game. So I'm giving you the program this time because I don't want you to have to spend the time this week writing it out. Plus, it's making use of some things that we are not yet getting to, but I want you to be able to just understand these components, get a first glimpse of them, and then be able to integrate it into your first Jupyter notebook. So this is different because the last Jupyter notebook you ran, I had put everything in. Now you're just putting in a component. Okay? Take a look at this. Add the other programming. It's just a Pi function that I'm adding a Pi program that I'm adding to that I want you to add to this last module. Maybe put in a header, make sure you can do all of that, and turn it in as your practice 8.2 today. Okay, stay well, everybody, and we'll see you later online.